In this video, we're going to look at all the solutions for all the limits quizzes. Now, we may go through them kind of quick, so if there's anything you don't understand, just make sure you ask me in class. First one says choose two correct statements about limits. First correct answer is going to be B, because limits are equal to a y value. The second one is going to be that in order for a limit to exist, both one-sided limits should approach the same number. On number 2, they want us to find the limit as x goes to a, so that's right here. You can see that it approaches a height of 2 from both sides, so it's just going to be 2. Find the limit as x goes to b, that's right here. You notice the limit from the left is 4, but the limit from the right is 3. So that's not the same number. We're going to have to say limit does not exist. And this one we're doing limit as x goes to d, which is right here. You can see it's approaching a height of 1 from both sides. So this one's just going to be 1. And last one, it's a one-sided limit, so the little plus sign means doing a limit as x goes to b from the right. So from the right, it's approaching a height of 3. So the answer is 3. Now in this example, they want us to graph this. So it's going to be this function everywhere except when x is 1. So that's going to be an upside down parabola, and it's moved up 3. And then when x is 1, the height is 3. So that's why you see that little point right there. Answer to this question was A. They want us to graph this piecewise function. When x is greater than -2, it's x squared minus 3. Now we're going to have to choose C, because you can see it's supposed to be when x is strictly greater than -2, but not when it's equal to 2. This one's filled in, so it's not going to be B. You still got to be careful. It might be none of these, so let's check. When x is less than or equal to -2, it's 2x plus 7. So you just want to make sure that this line is correct. If you plug in the points, you'll see that it is correct. You can try plugging in -2, for example. Plug in -2, you get 3. Yes, that works. And you can try a few more points if you're still not sure. You can also see the slope is 2. So you can see from here we go up 2 and right 1. So we do have a slope of 2. Correct answer is C. Okay, what we're looking at here is kind of like 1 over x plus 1. That's kind of like 1 over x, but it's moved left 1. So 1 over x moved left 1 is going to look something like this. Now the hard part of this problem is, what does this do? Well, when you plug in numbers that are bigger than 2, it does nothing. So it's still going to look like this. But when you plug in numbers that are less than 2, you're going to end up getting a -1, so it's going to reflect the rest of it. So you'll notice we have to reflect the rest of the graph. Correct answer for this one is going to be B. Okay, for this one, I want you to notice that there's supposed to be a hole when x is 1. You can get rid of A because there's a vertical asymptote for x equals 1. Okay, I also want you to notice that these are vertical asymptotes. So when x is 2 or -1, you get vertical asymptotes. Now for -1, you can see it's squared. So that means it's supposed to be the same on both sides. But over here, one goes up, the other one goes down. That's not the right one. You'll notice here it's the same on both sides. So that's good. For this one, it's an odd power. It's a power of 1. So when x is 2, you should have one going up and then the other one going down. So far, C looks really good. Let's check the last thing. Let's check the zeros. When x is 3, it's supposed to touch and cross through. You can see that happens. When x is -2, it's going to touch and turn around. You can see at -2, it touches and it turns around. Okay, last thing is the horizontal asymptote. You'll notice the coefficients are 1 over 1. If you multiply everything out, you're going to get an x to the 4 over x to the 4 as the leading coefficient, because there's 4 x's there multiplied together. So y equals 1 is supposed to be your horizontal asymptote. You'll notice you see it right there, y equals 1. So the final answer will be C. Okay, this is a pretty easy limit question. What is the limit as x goes to 3? So from the left, it's 1. From the right, it's 1. So this limit is just going to be 1. Okay, this one's asking, what is the limit as x goes to -2? You can see this is an example where there's too many fractions. So I'm going to choose J as one of my two choices. Now let's try to solve this and see if we can get the answer. We want to multiply everything on the top and everything on the bottom by 2, and also by x plus 4. Okay, if we do that, you can see at the bottom, it's going to cancel. You're just going to be left with a 2 there, and then these will cancel, and you just get x plus 4. Okay, don't forget to distribute this negative on the x and the 4. We can combine the 2 and the minus 4. Then we can factor out this negative. And now we can cancel this x plus 2 on the top with the x plus 2 on the bottom. Now we have kind of like a plug-in limit. We can plug the negative 2 in. Final answer is negative 4. So C is our other answer. Okay, for number 2, this one might look like it's an example for too many fractions, but if you just plug the 2 in, you get an answer. So really, this is just going to be a plug-in limit. Okay, we can simplify, and you can see we get 4 for our final answer. Okay, this one's going to be a factor and cancel example. The bottom is just the difference of squares. Remember, this should help you figure out what the factors probably are. Because that's x goes to 1, and that's creating a problem, we're expecting x minus 1 to be a factor. Now, if x minus 1 was a factor of the top, the other piece would have to be 3x and plus 5. Let's see if it works. The inside gives you 5x. The outside gives you minus 3x. So yes, that would give you the 2x in the middle. Okay, now that we've factored, we can go ahead and cancel. And now it's a plug-in limit. Let's plug the 1 in. Final answer is 4 for this one. Okay, this is a rewrite limit. We're going to want to rewrite it. We're going to leave 5 to the x. But 5 to the negative x on the bottom can be moved up, and it'll be 5 to the positive x on the top. Now we can just plug in the infinity. Final answer will just be infinity. Remember, if the limit does not equal a number, then we want to say that the limit does not exist. So this will be E for the answer. Okay, this type of limit is a conjugate limit. We're going to want to multiply by the conjugate of the bottom. Here we're going to leave the top, multiply out the bottom. Then we can simplify the bottom. We can cancel the x on the top and the bottom. And now it's kind of a plug-in limit. You can plug the 0 in, and you get negative 4 as your answer. Okay, here we're doing the limit as x goes to negative infinity. We want to look at the biggest piece on top, which is negative 8x squared. And the biggest piece on the bottom is going to be 2 square root of x squared. So that limit will equal this limit right here. Now I want you to notice I traded square root of x squared for absolute value of x. So that's the same thing as kind of like x to the power of 1, but no matter what, that piece will always be positive. Now when you compare the bottom to the top is going to win. We are plugging in a negative infinity, but that's not going to matter because here it's squared, and here the negative gets canceled, so there really is just one negative. So here we're going to say that the limit does not exist, and we're going to say there is no horizontal asymptote. For number 2, again, we're looking at the biggest pieces, so on top you get 30x squared, on the bottom you get negative 3x to the third. Because the degree on the bottom is bigger, you're just going to get 0. Okay, so that's going to be letter E. The horizontal asymptote will be y equals 0. Okay, biggest piece on the top is going to be 36x squared. Biggest piece on the bottom is going to be the square root of 4x to the 4th. So that limit right there is going to equal this limit right here. And you can see they're both x squared, so you can just take the coefficients and you would get 18 as your answer. Horizontal asymptote is going to be y equals 18. Okay, here they want to know all the asymptotes. They gave us a hint, telling us to choose 3. So that's nice. You can rewrite this fraction here. You can easily see the two vertical asymptotes, 0 and positive 2. Okay, for the horizontal asymptote, we want to look at the limit as x goes to infinity, and also the limit as x goes to negative infinity. But we get the same thing because we're really just looking at that right there, and we're getting 1. Coefficients are 1. It doesn't matter whether you plug in a positive infinity or a negative infinity because they're both squared. Okay, here they're asking, what do you have to find to determine if the function has a horizontal asymptote? Okay, we just talked about it in the previous question. We want to find the limit as x goes to infinity and the limit as x goes to negative infinity, and that's it. It told us to choose 2 answers, so it kind of helped us a little bit. Okay, for example 1, we're going to factor the bottom. And we're going to break up the fraction. We can also rewrite tangent as sine over cosine. Now, in order to use our rule for our special limit, we're going to need a 3 right here. So we're going to also have to put a 3 up here. We can move this 3 to the other fraction if we want to. Okay, so I'm doing the limit as x goes to 0 of all this stuff, but I can also give each fraction their own limit. So now I have two separate limits. Now there's a special rule for this first limit. That's just going to equal 1. And for the second limit, I can plug in a 0 for the x. Since cosine of 0 is 1, I really just get 3 over 5. So the final answer is 3 over 5. I choose E. Okay, for this limit, we're going to break up the fraction into two pieces, and each piece will get its own limit. Okay, on the first limit, we're going to bring the 7 to the outside. On the second one, we're going to factor out the 3, and we can even bring these numbers to the outside because it's just a constant. Now we have a special rule for this one. That's going to be 1. We have a special rule for this one. That's going to be 0. Final answer is going to be 1 over 7. Okay, this limit is just going to equal 0, and the reason is because we have, if you just plug in the 0, we have 0 times sine of some number. We know about sine, the biggest it can become is 1, the smallest it can become is -1. So it's never going to be infinity, so we won't have 0 times infinity. We just have 0 times a number that might be as big as 1 or as small as -1, and that's going to be 0. So this one you had to solve using a little bit of thinking. Final answer is A. Okay, for this limit, we need to see what is the biggest piece on the top and what is the biggest piece on the bottom. We'll rewrite this. That limit would be the same answer as this limit. Okay, I think you can see the top goes to infinity faster. So your final answer will be infinity. Don't forget to count the negatives. You do have one negative down here on the bottom. So final answer will be -infinity. Choose F. Okay, for this one, if we were to plug the -infinity in, it would kind of be something like this. And because both powers are negative, you can move them and they will change to positive. Now let's approximate E so that we can see which one is going to infinity faster. Okay, you can see that the bottom is going to infinity faster, so this answer will equal 0.